So one may ask, why a dynamical system? So dynamical system mathematics in applied dynamical systems is very, very interesting. Any system has certain variables. Let's call those variables at any given time. Let's call that x of t, right? But these variables can be transformed probably by internal forces within that particular system. Let's call those internal forces by matrix A. So matrix A might change the state of a system. But not only matrix A can change the state of a system, there might be other forces coming from outside can also affect the state of the system. Let me call that f of t. So imagine you've got a system and the internal factors affects whatever that is happening in a system, and then the external factors also affects what is happening in a system. So by the end of the day, the system will change and we ended up with a new state, which I may call x prime of t. Well, so how do we solve this kind of a problem? So to solve this kind of a problem, in another video, remember, we explain how we solve these ones of the form. So this one is non-homogeneous, but we have explained how we can tackle these homogeneous equations, right? So to solve this one, what we have to do here is that the first step, we need to understand that if we solve this, we're going to see that x of t by the end of the day is x of t for the complementary solution plus x of t of the particular solution. But we spoke about how this complementary solution is calculated when we delved into this kind of a problem. Remember, we said that the complementary of x of t is equivalent to phi of t, where phi of t is the fundamental matrix, right? So it's going to be phi of t times c. That's what we've explained as far as this is concerned. What about this one? Because this is a new animal now. What about the particular solution, right? How do we calculate the particular solution? So what we can do, let this particular solution to be equivalent to what? To be equivalent to phi of t probably times u of t, where u of t is just an n by 1 matrix. All right. So let's try to differentiate this. So if I try to differentiate this, by the end of the day, by product rule, I'll get phi of t, right, times u of t prime plus phi of t prime times u of t. So here you need to be very careful because remember, this is an n by n matrix, but this is an n by 1. So order matters. Don't ever try to put u of t here or try to put u of t here. Otherwise, the whole thing will be messed up. All right, so now at this particular point, what do we have to do next? But remember, what is x prime of t? What is x prime of t? So we know very well that from this question, we know that x prime of t is equivalent to a of x of t plus f of t. So it's analogous to what? To phi of t times u of t plus the derivative of phi of t times u of t. But we know who is x of t, right? We know very well that x of t, we've already deduced it here when we let x of t be this item. So here I can substitute with a times phi of t times u of t plus f of t is equivalent to phi of t times u prime of t plus phi prime of t times u of t, right? If you take a closer look at what we have right now, you can tell that if you look at this item, right? If you look at this item, right? What can we do to this particular item? This one, phi of t times u of t. Remember, we know very well that in this particular case, in the complementary solution, if c, remember c is just a constant, so when c is equivalent to 1, you may find out that the fundamental matrix phi of t will be equivalent to x of t, right? So what does that mean by the end of the day? So if we go back to this problem, we can realize that a times phi of t times u of t, which is equivalent to f of t, is equivalent to what? So if phi of t is equivalent to x of t, yet we know very well that from this equation, x prime of t is equivalent to a of x of t plus f of t. So if x of t is phi of t, then what can we conclude? We can also conclude that the derivative of phi of t is also equivalent to a times what? Times phi of t, right? So where there is a derivative of phi of t, right, I can replace with a times phi of t. So this one, for the meantime, I can keep it as it is. So this will simply give us, so there was a plus here, so this will keep us phi of t times u prime of t, plus where there is phi of t, I can replace with a times phi of t times u of t. Surprisingly, this item and this item disappears. So what we ended up with this, which is u prime of t times phi of t is equivalent to f of t. Surprisingly, what will happen if I multiply here by phi of t? Let me try to do that. But remember, like I explained, there's no way you can start with this followed by this. So let me keep it the way it is. Why? Because this is an n by n and this is n by 1. Otherwise, the matrix will not be defined. So for this to be defined, we come up with phi of t times u prime of t is equivalent to f of t. Let me try to multiply both sides by the inverse. So the inverse, right, of phi of t times phi of t times u prime of t is equivalent to, so I also have to multiply here by the inverse, is equivalent to the inverse of phi of t times f of t. So obviously we know that this gives me an identity matrix. So an identity matrix times u of t, I'll still remain with the u prime of t, right, which is equivalent to phi, the inverse of phi of t times f of t. So if I want to remain with u alone here, I can integrate both sides. I can integrate this side, I can also integrate this side. So I can realize that u of t, right, is equivalent to what? To the integral of phi, the inverse of phi of t times f of t. But remember, our target is to calculate this particular solution, right? So what is our particular solution? So by the end of the day, we can see that our particular solution, right, is equivalent to phi of t times u of t. But we've realized that u of t is equivalent to this. So it's going to be phi of t times the integral of the inverse of phi of t times f of t with respect to t. So this is our particular solution. So by the end of the day, if you want to find the general solution of this problem, what will be the general solution of that problem? So the general solution of this problem is x of t is equivalent to, what is the complementary solution? The complementary solution is equivalent to phi of t times c plus, what about the particular solution? The particular solution is the one that I've deduced here. So it's going to be phi of t times the integral of the inverse of phi of t times f of t dt. So this is the solution to a non-homogeneous differential equation. Like I say, in any system that you want to study, especially those systems that are influenced by external forces, right? This equation will help you to understand any system that you might be interested to study in a better way. Awesome.